All right. Well, good afternoon, everybody. Thank you for coming inside for a little bit of time this afternoon. I know it's a beautiful day out, at least here in Vermont in St. Albans, and even warm out. So it's definitely tempting to be outside, but I'm really glad that you came in to join us. Hopefully, you're getting to enjoy a little lunch too for our third webinar in our dairy production series this winter. And today we have Dan McFarland, who's joining us from Penn State University. And Dan is an ag engineer educator with Penn State. And he covers much of the southern part of the state, which is a pretty big state. So it's a good size area. And his program emphasis involves animal shelter and environmental systems design. He works closely with producers and ag professionals on issues related to new design and also improvement of existing facilities. So he's been working a lot with farmstead design and layout, animal comfort and well-being, ventilation systems, resting and feeding area design, heat stress, which is a little hard to even think about right now, but I mean, after last summer with it being so hot and dry, definitely could happen again this year, and also watering systems. So I'm really excited to have Dan with us. We all know that comfort is important for our livestock, important for us. And I when we were brainstorming with our advisory group, everybody started talking about cow comfort, and I had realized it really was a topic that we haven't covered much over the last few years. So it was great, and many people recommended Dan and his vast knowledge around this topic area. So before I turn it over to Dan, I just want to thank our sponsors of the Dairy Education Series, the USDA and Northeast SARE, have all been wonderful sponsors of our programming. And as you can see, Susan has put up a poll. We made this poll up, Dan, for you and for others, just asking folks how they would rate the comfort of the cows on the farm, and just giving us a sense of how you think the cows are doing comfort wise. And it looks like pretty good. So there we go. Let's see, what else do I need to cover? We will continue with our series next week. And even though I think everybody heard that Sid Bosworth was retiring, we've already brought him back out of retirement to speak with Kurt Kotanch. Next week on forage quality, we'll be hearing about local research projects and also a focus on corn and corn silage. So please be sure to join us next week as well. Same time, 12:30 to 2. All right. And here we go. We have our next poll question. We're just really trying to push people to do just a little bit of homework as well. Now, Dan, I don't know if you want questions during your webinar or if we should try to get through the presentation and then take questions at the end. What
Heather, feel free to interrupt me anytime.
Okay.
You know, if it's a pressing question and so on, I have no problem with being interrupted. We'll get through that. Yep.
All right. So please type your questions into the chat box, and as they come in, I'll start offering them up to Dan for him to answer.
First of all, I'd like to thank the University of Vermont Extension Dairy team for inviting me to be a part of this webinar today. I sincerely hope that the information that's presented in the following slides will be helpful as you consider cow comfort in your facilities and the possibility of improving them. One of my mentors always used to start his presentations with the summary because he figured that people would probably get more out of the summary than they did at the end of the presentation because they might not be with him. So I'm going to follow that strategy today, at least on part of it, and offer you 7 ways you can improve cow comfort and productivity on your farm, because usually things can be improved. in some way. There's so many things to take care of on a dairy farm that you can't do everything at once. And so maybe, looking and focusing on one particular area and making improvements might help. But here's what I would suggest. First, look at improving air quality, especially during the winter months when things tend to get closed down as far as air exchange, and you get moisture buildup and some of those things. Cows like fresh air. And so improving the air quality in the barn is certainly going to improve their health and performance. Increase the bedding amount and frequency. That always works as far as improving cow comfort, stall use, and also reducing injuries. Have feed and water available at least 21 hours a day, and have cows available to feed that amount of time too, so that the two come together. It's a behavior that we really like to see, and so let's do the best we can. Provide relief from heat stress. Now here in Pennsylvania, we get plenty of it during the summer months. You'd think Vermont, all we think about is skiing and cool weather and things like that, but I've visited Vermont in summer months, and I know it gets hot up there too. So I think the cows would appreciate some relief from heat stress. Also, increasing alley and stall cleaning frequency. It just helps keep the cows cleaner, more fun to milk. And so keep that in mind. Don't overcrowd groups. And if you do, there's some management changes that probably need to take into effect, because overcrowding groups does affect their behavior. And we want to minimize that. And then also allow more space for special cows. Now, I know they're all special, but a couple things to keep in mind is, first of all, every cow in the herd needs treatment of some kind during her lifetime, during her lactation, and has to be isolated from the group and taken care of. So facilities that allow that are important. And then also we think of special cows being more in the transition to post-fresh stage, where a lot more research and studies been done showing that these cows need some special care during that. And so allowing more space for them is always helpful. So the Oxford Dictionary says comfort is a state of physical ease and freedom from pain and constraint. So just put cow in front of that, and this is what we're trying to achieve when it comes to cow comfort. The United Kingdom Animal Welfare Council put together these 5 freedoms, and they're often noted as kind of a guideline of how cows should be treated. First is that freedom from hunger and thirst. Have enough feed and water available to them so that they can maintain their full health and vigor. Freedom from discomfort, providing an environment, shelter, that's going to protect them from weather extremes, as well as provide a comfortable resting area. Freedom from pain, injury, and disease. We want to minimize all those things, but if they do happen, we want to have the opportunity to rapidly diagnose it, isolate them, and take care of that problem so that they can recover more quickly. And also freedom to express normal behavior, have sufficient space and proper facilities and in the company of animals of their own kind so they can express their normal behavior, which is what we're kind of after. And also there's this freedom from fear and distress, and that's a little hard. I don't know if I want to know what a cow is thinking, but I do know they know what fear is. And so I think this comes down to just how you're handling those animals, and be patient with them, try to keep the fear and distress down. And so a guideline for housing I've always tried to use, because I look at cow comfort from an engineer's point of view, is how can we create this environment that is going to allow them to have this normal behavior, keep them healthy and performing, but also protect them from weather extremes and so on. And I don't think we have to apologize for putting cows in shelter, as long as that shelter meets their needs. And a guideline we use is when cows are moved into shelter, the environmental conditions need to be similar or better than what's assumed outside. And that comes into heat stress and cold stress as well. And so we want to have that environment to be, something that would be similar to what it would be outside, or better. So the benefits of cow comfort are pretty simple. Improved milk production usually comes with cows that are fed and watered properly, have adequate resting time, and treated right. They're probably going to improve their milk production. And milk quality, if things are clean, then somatic cell count tends to go down. If they're not injured, they're going to perform better. Improved health, of course, reduced lameness. When this comes, cows, as we'll talk about, tend to rest 10 to 14 hours a day. If there's excessive standing, there's more opportunity for lameness to occur. And then, of course, improved reproduction. And this partially comes in tune with heat stress relief, is having viable embryos during that time, so that there's conception and we have a calf that's growing. And then improved longevity. And really, the most productive cows in the herd are the ones that are most affected by comfort or the lack of it. And so we want to keep that in mind. So just on this improved longevity for a minute, I mean, if you can keep a cow one more lactation, you have that additional milk production. There's one less replacement that you have to purchase. There'll be another calf, and then it's going to reduce your overall cull rate in the herd. And a dairy educator in Lancaster County a number of years always used to hammer this on me, just how important cow comfort was to this improving longevity. And I think it is probably, we all want more production and that type of thing. But keeping cows in the herd longer is really, when it comes to the bottom line of a dairy farm, is keeping productive animals in the herd longer is really a very beneficial thing. And so there's going to be those less involuntary culls, and so hopefully the genetics of the herd will continue to improve. So that this dairy educator used to talk about this power of one more lactation. And so just in this example, we'll look at a herd that has a rolling herd average about 24,000 pounds. The milk price is $17 per hundredweight, and a replacement cost, basically the cost here estimated of raising a heifer prior to calving, $2,000, and then perhaps if you're culling a cow, you're going to get a cull price for her. So the replacement cost is about $1,300 in this example. All these numbers can change, but the idea, I think, is pretty solid. So we got this cow that comes into the herd at 2 years of age. Her first lactation, she's giving around a little over 20,000 pounds of milk. Her profit per year, because you got to feed the cow, take care of her, a number of things come in, is about $507 in this example. Now the replacement cost, this case that we've got to pay for her raising basically, but this $90 it shows is we don't have a dry period to take care of her. So we assume that. So her lifetime profit is now minus $792. Now she goes into her second lactation, production improves a little bit, the profit improves, but still she hasn't paid her raising off yet. And so now we're in the third year. Her production has increased. She's got a profit that year of $869. She's finally in the black. She's out of the red. But if you cull this cow, who's only about 5 years old, if you cull that cow, that's her lifetime profit. If you can keep her one more year, hopefully her production will increase, her profit will increase this $980. So her lifetime profit now is significantly more. And if we can keep her even one more year, now we have a lifetime profit of that cow over $2,500. And so that's something to keep in mind when we're looking at trying to improve cow comfort, is how can we keep cows healthy and in the herd longer? So as an engineer, I look at these things, and these are what I've come down to the basic housing things that we need to consider. Excellent ventilation, a dry, comfortable resting area, good access to feed and water, a confident footing, and then protection from these weather extremes. These are the things that allow animals to be more productive in dairy housing. But we also want to consider the caregiver, their ability to observe and have access to each one of those animals, to simply sort, isolate, and restrain those animals when necessary, with little disruption by the cow or the caregiver. Convenient feed delivery, efficient manure collection, expedient housekeeping, just to make things easier so that these tasks get done when they're supposed to. And also worker safety. We don't want to endanger especially hired labor or family labor for that matter. We want to keep them safe. And these are the things that allow caregivers to be more productive. It's also important to kind of understand typical cow behavior. Cows eat around 12 meals plus or minus a day. It takes 20 or more minutes per meal. So they're eating maybe 3 to 7 hours per day. So we want to allow them the opportunity to get those smaller meals more frequently because they're just going to process them a lot better. Cows rest 10 to 14 hours a day. We like to see it on the upper end of that. Of course, the amount they do rest is going to depend on their age and stage of lactation and also gestation. That will vary, but we want to see 12 to 14 hours a day to get them off their feet so that they're not standing excessively, and providing that comfortable area for them. They're going to drink 20, 30 or more gallons a day, depending on the ration that they're offered, their production level, and the amount of dry matter that they're eating. Ruminate 4 to 10 hours a day. We want to again see that on the upper side, in that 8 to 10 range if possible. And they're going to do the majority of that when they're resting. So we want to provide the opportunity for that. They also do some other things. They urinate and defecate quite a bit. And so we need to take care of those things. But, dairy cows are prey animals. They like to do things as a group. There's protection in numbers. And so when they feel stressed, they tend to come together. And so we want to keep that in mind as well. If you put that in a pie chart and look at it, you look at the resting time and eating time takes up about 75% of their day. Good work if you can get it in that case. But we need to look at that and see how important these two areas are to the overall cow comfort in the facility. To troubleshoot cow comfort issues, we need to measure things. It's going to be length, width, height of stalls, of feed area, of alleys, of things like that. Also, how much time does it take to do these things that the cows are doing? And then percentages when it comes to, overpopulation or things like that. We go into percentages, and you need to take time to observe those cows. I know things are busy, but if you can observe, that's going to take time, and that's where time-lapse photography, and I use that quite a bit. I've got 5 time-lapse cameras, and 2 are usually in use at some farm somewhere, trying to look for things in either cow behavior or management that might be improved on the facility. I've included handouts with this presentation, and one is John Tyson, who's another ag engineer with Penn State, and I put together, it's these dairy facility risk factors, and they cover these areas of feeding, water, air quality, heat stress abatement. They're just a real general guideline, giving you an idea. Here in the feeding, we kind of say that, if you've got feed space of over 24 inches per cow, then that's probably a low risk. But in the 16 to 24 inches, that's medium. And if it's less than 16, that's a high risk. And really, there's some things that even good feed management at the bunk can't take care of there. So that gives you an idea that we have it in low, medium, and high risk categories for these for these topics. So let's start with ventilation. W.D. Horde recognized back in 1885, what does a cow live on? She lives on food, drink, and air. And you take away the air and she will die the quickest, won't she? And so air quality is really, really important. And so we want to, what do we do to get excellent air quality? First of all, we want to control the level of moisture, gas, and pollutant levels. Cows just breathing produce somewhere between 3 to 8 gallons of moisture a day, depending on the temperature outside and some other factors. But we want to control that, as well as the gases that are produced by the cow and manure, as well as any pollutant levels, the dust and dander and feed and feed particles, things like that might be in the air, and the viruses that may be attached to those things. And so you want to take care of that. We also want to provide protection from weather extremes, whether it's cold wind and precipitation or heat stress. And then we need a proper air exchange for the season. When it's colder weather and more windy, we want to provide a different level of air exchange than we would during a hot sunny day. And so the recommended kind of the guidelines we use is a cold weather rate, which we consider the minimum rate. No matter what the temperature is, we probably need somewhere in the range of 4 to 6 air changes per hour. Then there's the mild weather rate, which we're getting into now, looking at 12 to 15 air changes per hour. We get into April and May, it's going to get up to that 30 air changes, what we call the warm rate, 30 air changes per hour. And then during hot weather, we want to just make this building a pavilion or provide air exchanges in the range of 50 to 60 or more air changes per hour. So the goal is to provide air quality inside the building equal to air quality outside the building, with mainly respect to moisture, gases, and odors and pollutants, but also temperature at times of the year. Natural ventilation systems depend on the wind to provide pressure differences between the inlets and the outlets of the building. During colder weather, Temperature differences can create that. Warm air rises, and so these furnaces that are contained within that barn are creating heat, and that can help drive the air exchange. But usually wind overtakes that. And so wind, speed, and direction are very important as far as ventilation design. And so I often tell people the advantage of natural ventilation is wind speed and direction determine the air exchange. The disadvantage is that wind speed and direction determine the air exchange. So then when there's periods of little airflow, then you're maybe not getting the air exchange you need and might need some other methods to help blend that air and move that air. So in looking at the design of a building, we want to put the long axis of the building within 45 degrees of the wind direction. We want to look upwind of the building and see what's in the way as far as blocking blocking good airflow to animal level. We say a minimum of 50 feet from an upwind obstruction, but it depends on what that upwind obstruction is, whether it's a building or silos or topography, that type of thing. We really like to see 75 feet or more between buildings, and even depending on the building you're building, depending on its width and height, we might get up to as much as 100 to 200 feet between buildings. And then you want to look at what's available as side and end wall openings. I mean, at the beginning of my career, some of these buildings had a 9-foot sidewall with a generous 2.5-foot opening at the top that you open during the summer. Now we look at building sidewall heights that are in the range of 12 to 16 feet high, with 11 square feet of opening on the prevailing wind side available in the summer to allow air to get through. And then is that opening adjustable, easily adjustable, to provide protection from wind and cold weather, keep rain out, that type of thing. And there are some excellent automatic controls for curtains now, which sense inside and outside temperature and make the adjustments automatically, and work very nicely, and I think should be incorporated in just about all natural ventilation systems. And then a ridge opening, probably in your area, a minimum of 2 inches per 10-foot of building width. Down here in southern Pennsylvania, we look at 3 inches per 10-foot of building width. So natural ventilation management, cold weather, if the building is warmer than 5 to 10 degrees Fahrenheit than what it is outside in the shade, you're probably looking at some air quality issues, primarily too much moisture. In hot weather, about the best we can do is in the building is 1 to 3 degrees Fahrenheit warmer than it is outside in the shade, and simply because we have all these furnaces in the building generating heat. Mechanical ventilation systems, which usually come into play in tie stall barns, the exhaust or negative pressure system is what's used mostly. Is the fan is lowering the pressure inside the building, so now the higher pressure outside wants to come in through these uniform inlets, fresh air inlets throughout the barn to provide good air mixing and exchange. The rates for those, we figure the minimum or cold weather rate for a cow that's in the range of 1,400 pounds or more is about 50 CFM per cow. Mild weather rates 250, double that for the warm weather rate, and then up to 1,500 cubic feet per minute in the summer to get rid of excess heat and moisture produced by those cows. That's going to require, though, a system that really is designed to deliver from 50 to 1,500 CFM per cow based on the conditions that are outside and inside the building. And so that's going to require multiple fans, usually at least 3 in a building to take care of the different seasons and provide more uniform temperature and air exchange control throughout that range that we're talking. Adjustable inlets that will match the capacity of those fans to provide good mixing as well, and then accurate controls so that we're sensing properly how that system needs to work. Quite often that's done in tie stall barns. Here you see in the blue are some exhaust fans for this particular barn, and then the magenta rectangles around are inlets. So the fans lower the pressure in the building that equally distributes that warm or that fresh air coming into the building throughout the areas where the cows need it. At the end, they breathe that, and also mixing in the building and then exhausting out the fans. So because tie stalls are mainly better insulated than freestall barns and bedded pack barns, we look for temperatures in there we allow some cow heat to maybe keep the temperature between 40 and 60, which is temperatures that cows really like. And then in hot weather, again, about the best we can do is 1 to 3 degrees warmer than what it is outside in the shade. So while we're talking about hot weather, we'll just say that milk production and reproductive efficiency are reduced by heat stress in dairy cattle by high ambient temperatures within all humidity ranges. Whether, wherever you are in the United States, heat stress will occur. So we look at the cow, and cows are homeotherms, which basically means they can maintain a constant body core temperature through a pretty wide range of temperatures. And so their lower critical temperature for dairy cows, because they come from colder regions, their origins are in colder regions, is 0 degrees. That's their lower critical temperature. The upper critical temperature is 77 degrees. And so that's what we call the thermoneutral zone for a dairy cow, is in that range. That's where their heat production rate and body core are pretty consistent throughout that. There's also the cold zone below that, where the cows are really trying to produce heat. They're using all they can to do it, but it gets to a point where they could succumb to hypothermia as a result. And then there's the hot zone, which is above 77 degrees, where they're trying to get rid of their heat, but they just can't. And so it ends up with death due to so in extreme cases, due to hyperthermia. So really another range here is this thermal comfort zone of a cow, which we figure is about 30 to 70 degrees. And that's where cows really like to stay, is in that zone. The cold zone is from 0 to 30. But something to note here is that the warm zone, just before the hot zone, is from 70 to 77. The thing to note here is that cold zone's got a broader range than the warm zone. And so we really need to look at heat stress relief and not necessarily worry when it gets, below freezing. There are things we can do to keep cows comfortable in colder weather with bedding and more calories and protection from wind and cold precipitation, that type of thing. But on the hot zone, there isn't much we can do other than, consider these heat stress relief. Heat stress is basically cows that are their ability to gain heat is greater than their ability to lose it. It's that simple. And time plays a role too, in that the goal is to balance that heat gain. A cow can heat up during the day, but if she can bring her core temperature back down to normal by morning, she's going to be fine. But the problem is there are some outside weather conditions that don't allow that core temperature to get back to normal by morning. And if that goes on for maybe 2 days or 3 days, all of a sudden you'll see production slumps, dry matter intake down, and they're suffering from heat stress. Heat stress affects lactating cows from dry matter. Milk production and reproductive performance is reduced, and lameness is increased simply because they're probably standing more. They stand more because they're exposing more of their body to the environment in an attempt to get rid of the heat than they would if they were resting. It affects dry cows on their subsequent lactations reduced. Dry matter, body weight, body scores usually go down during the dry period, and their immune status during this period is also reduced. And it affects the unborn calves because the cow is using energy to try to keep herself comfortable. She's taking energy away from that calf's development. And so birth weights are usually lower, their immune status goes down, and this follows their performance all the way up through heifer growth as well. So when do you need heat stress abatement? Now, these were some recommendations that Dave Bray and Ray Buckland in the University of Florida. And in the East here, where we consider it a humid climate, we look to Florida because they have similar conditions to we do, only they have them just more months of the year. And so their recommendation was select 10 cows on a hot day and take temperatures. If 8 of 10 or exceed 102.5, they need heat stress abatement. You can count their respirations. Again, look at 10 cows, count their respirations. If they're over 80 beats per minute, breaths per minute, they need it. And we'll talk about that as well. And then if dry matter and milk production go down by 10%, they need it. Now, in that respiration rates, there's been some research here kind of looking at that, is that the normal respiration rate of a cow is somewhere between 40 and 50, 55 breaths per minute. But you can see by this chart here that at 102.5, all of a sudden these cows are breathing at about 60 breaths per minute, and at 80 breaths per minute, they're way above 102.5. So probably it's too late. And so we ought to consider, trying to keep the cows at their normal rate. And so apply heat stress abatement methods maybe sooner than what was recommended down in Florida. So my cohort, John Tyson, another ag engineer at Penn State, looked at some data at Burlington, Vermont, and it was about hourly data for about 5 years. So there's about 44,000 data points in that, and made up this chart, basically looking to the one we looked at before for, what's happening near Burlington, Vermont. And so cows, based on the temperatures in that data, found about 64% in the thermal comfort zone, which is good news. The cold zone, 19 for between the cool and the cold, but less than 1% was in that cold zone during that time. But we look at the heat stress portion, almost 18% in the warm and hot zone, and then above the critical temperature about 8% of the time. Not necessarily the same as what it is in the area that I'm at. We're a little warmer during the hot weather and not quite as cool during the cool weather. And so, but still, there's the need for heat stress abatement for a portion of the year to consider. One of the metrics that's used in determining, whether a cow is under heat stress is the temperature humidity index, because it, in some areas you go to, it's not the heat, it's the humidity. Well, it's both that really make the difference. And so this is the equation that's used using dry bulb temperature and relative humidity. And what the studies kind of indicate that generally dairy cows are stressed when THI is greater than 72. There's no Fahrenheit here. It's just a number in this. It's an index. So high producing dairy cows, and that would be those that are, 80 pounds, 85 pounds or more, they start to feel a little lower at that 68. And then there's been evidence of pregnancy loss as soon as 60 to 64 THI, because those eggs, just aren't viable. But what this doesn't take into account is radiation or airspeed. So for instance, if you can get cows, if cows are out exposed to direct sunlight on a hot day, that THI, or when they start feeling heat stress, might be much below what's suggested here in these numbers. But if it's in a shaded area with airspeed over, it might be a little bit, you might be able to get a few units above that. This is a line, again, John Tyson prepared for this presentation actually from that Burlington, Vermont data, looking at temperature and humidity, the THI index here in Burlington, Vermont, when temperatures were greater than 60 degrees. So if we look at, say 68 degrees, all these little data points here, these little circles you see are those hours that are in that 44,000, or as a portion of that 44,000 data points that were there. And while you see some of them spaced apart, these dots are also stacked. So if it was in 3D, it's like checkers, they'd be stacked on each other. There's a good portion of the time in Burlington that the temperature, the THI, the temperature and humidity combined are in these ranges where heat stress abatement should be considered. So, okay, Dan, we need it. What do we do with it? Well, reducing heat stress, we use the acronym SAW, SAAWW. And what that stands for is first shade. Get cows out of direct sunlight, out of shade to reduce that radiant load that's on them. Look for air exchange to get rid of moisture gases and odors, as well as excess heat. And then air movement over the cow to provide the opportunity for them to more efficiently get rid of their heat. And then we need extra water for drinking and also for cooling. So air exchange is really important. We want to get that warm, moist, stale air out and get fresh, dry air in as much as we can. It can be driven either naturally or mechanically, but we're looking at least one air change per minute as kind of a guideline of what we want to do. And then again, as I mentioned earlier, about the best you can do is 1 to 3 degrees warmer than what it is outside. All other heat stress abatement methods that we'll mention now won't work with poor air exchange. And so,
Dan,
yes,
can I ask you a quick question?
Absolutely. You can ask a long one.
Well, somebody, Diane is asking, at what temperature do you recommend the fans in freestalls turn on, and I guess that would be on sort of, probably either end of the spectrum.
Yep. I think the goal with heat stress abatement is not wait till they're heat stressed, but try to get it before. So in fact, one of the studies that we've done, we had a farm that actually was turning their circulation fans on at 70 degrees, and you could see cows bunching, but when they set it at 60 degrees, then there was more normal behavior as far as resting and feeding and that type of thing. So I would guess, in that range of 60, 65 degrees is probably where we want to start putting circulation fans and things like that. Of course, with a mechanical ventilation system that has thermostats or sensors, that will probably kick on about the same time. That cow's comfort zone is at 40 to 60 degrees. And I gave a ventilation presentation on that one time and talked about, in summer, that's what cows would really like, 40 to 60 degrees. And a producer asked, what do they want in the winter? I said, well, 40 to 60 degrees. And so, that's what they want. We want to try to do that. So I would say fans should probably come on about that 60 degrees. And that would provide, I don't think they'd mind a bit.
All right. Well, thank you. I'll let you
Very good.
continue on.
So as far as air exchange in naturally ventilated buildings, we want to just open things up and just make this a shaded pavilion for those cows as much as we can. But that's going to depend on the site and the orientation of the building and a lot of things that come into effect how successful that will be. And so there are some mechanical options to consider, and that's tunnel ventilation. And certainly tunnel ventilation can be combined with natural ventilation and just used during warmer weather. There are some design considerations to look at to make that work successfully. Cross ventilation kind of makes you be a fully mechanically ventilated building because they're not naturally ventilated buildings. They're using fans year round. And there are, again, some design guidelines that you really don't want to ignore in this type of as well. And then there's this hybrid, which is a little bit different idea. It's a naturally ventilated building until the temperature gets in the 60s. And then these fans are actually exhaust fans that are blowing in. The curtains are closed, and then these fans are blowing in to provide a pressure ventilation system for the air exchange, as well as providing air movement over the stalls. So you've got some options in that case. As far as forced convection, that air movement, it helps carry heat away from the cow's body. And also if you're using spray cooling, or even cows do sweat a little bit, it will increase their rate of evaporation, aiding in their comfort. We look for, minimum air speeds. This would be away from the fans, before the next fan kind of thing, 3.5 to 5 miles an hour. There's some research looking at 5 to 8 miles per hour. And it seems like reproductive performance improves if we go to those faster air speeds, but still some work needs to be done there. So we want to see fans over each row of stalls, and generally we look at putting them 8 to 10 times their diameter apart as far as spacing. We want to have fans at the feeding area. And just I'll mention here, we've done some work down here where we actually just, rather than blowing with the predominant prevailing wind in one direction, we've put some facilities in where actually fans are blowing from each end towards the center. You don't need any more fans, you just need to space them properly. And it seems like cows spread out more. And I don't know why. And when cows start telling me why, speaking to me, I'm going to get out of this business. But in observing them, it seems like cows like to face a breeze, and so it gives them more options to face, and perhaps they spread out in according to that. Also, wind direction changes from day to day as well, and so it might help benefit in certain times of certain days that you got fans that are blowing in that direction as well. So in tie stall barns, typically tunnel ventilation has become very popular in summer months to provide that rapid air exchange. Fans at one end, inlets at the other. Rapid air speed, so we're looking at rapid air exchange, less than 45 seconds in most of these barns. And then we don't often need, however, people are adding circulation fans over the stalls in tunnel systems, but both the exhaust fans here are providing both a cooling breeze and that rapid air exchange at once. So cows tend to drink 25% more water during hot weather, because one of the ways they cool themselves is by breathing. and they're evaporating that moisture from their lungs and esophagus. And so that's absorbing heat, body heat, and exhausting it out with their breath. We also use spray cooling primarily in freestall and bedded pack housing along the fence line, where it's direct cooling. You're soaking the cow to the skin and then evaporating that moisture off of her skin in intermittent sprays and fans. And so it's the same thing as, sticking your hand in a pail of water, putting it up in the breeze. It's evaporating and pulling that heat directly from the body. In humid climates, this is the preferred method. There are what we call indirect evaporative cooling systems, evaporative pads that are sometimes used in conjunction with tunnel ventilation, as well as high pressure misting, again, used in conjunction with tunnel ventilation. The idea here is you're evaporating, as you're bringing air in, that air is picking up moisture, and that evaporation of that moisture lowers the dry bulb temperature in the building. And so you have a greater temperature difference between the cow and the environment. And so you have a bigger gradient to pull heat away from the cow. But it can be effective too, as long, these can be very effective. All of them can be very effective unless it's really hot and humid, and then their effectiveness is a little less. But in all of these systems, because moisture and heat are being added to the animal space, that air exchange and forced convection become really essential in order for these systems to perform properly. So moving on to, resting area. Cow dairy, we mentioned dairy cows like to rest 10 to 14 hours a day. I feel very comfortable with good design and stall management. We can achieve these rates in freestalls, tie stalls, bedded packs, and also compost bedded packs. Locomotion scores are an indicator of stall use, reluctance, and refusal. Generally, if there's a lameness issue, one of the first places you want to look at is how are the stalls? Are the cows using the stalls, and are they using them properly? Because generally, if locomotion scores go up, then it's excessive standing that is causing that. The farm goal is to have 95% of the herd or more of the herd in the 1 to 2 category here, and none in the third. Hock and knee lesions are an indicator of resting surface cushion, comfort and condition. Usually has to do with the amount of bedding and the type of surface that they're resting on, and the amount of space that they have resting on, as we'll get to. There's that rear leg movement that creates that abrasion, and then also later on the swelling. And then hygiene is an indicator of stall management as well as cow alley management. The first step in a freestall facility where the cow puts her foot in a freestall is right where she's going to place her udder. And so you want to have the alleys clean as well, so that you reduce the amount of manure that is brought into the stall when the cow enters it. A lot of benefits to a quality resting area: that reduce stress on the feet, which is going to lower the incidence of lameness, less injuries if the stall bed and the bedding are right. Cleaner cows increase longevity, again, because they're of these lack of injuries and so on, and then improve milk production because they're ruminating more efficiently when they're resting than if they're standing. And this study indicated the greatest effect on poor stall design may be on lame cows within the herd, because they don't get lame and recover, they get lame and get worse. So some of the common resting behavior or postures that we see is this short position. It's a very important one, where her head's back on her ribs. It's her deepest slumber, and it happens about an hour to 90 minutes a day. It's very important. And so the stall structure and the space there needs to allow for this one. Then there's the narrow posture, which is pretty much she's resting vertically, but she's also extending one or both of her front legs out from her. It could be about 25% of her total resting time. And so we want to allow that opportunity in the stall for her to do that. Then there's a long position where her legs are tucked in under, and then the wide position, which they're a little more lateral in the stall and extending their front and rear leg to the side. we look at the physical components of a freestall. The dimension, structure, stall bed, and bedding are all important, but we've got to provide adequate body space so that they can rest up on the stall, head space when they're resting and head to the side, that there's room to do that. And then also lunge space. And lunge space can vary with the cow anywhere from 3 to 4 feet ahead of her foreknee when she gets up. And so we want to provide that space in front of there so that she can do that. Cows can lunge to the side and get up, but they really don't like to. They only do that if they have to. It should only take about 5 to 10 seconds for a cow to rise. I've observed cows that take 90 seconds to get up. We call it ratcheting because they don't have the space, and it's not a continuous motion. It's a lot of little motions to try to get them up, and it's kind of painful to see. So for freestall lengths, closed front stall, it might be up against a sidewall, 8.5 to 9.5 feet long. Open front stalls, which might be head to head or just open, 7.5 to 8.5 to give them adequate space to do that. And this should be determined by the largest cows in the group, or the stalls will determine the largest cows in the group. If you don't have that kind of space, some things you can do. Here's an example on the left of extending the bottom portion of the wall and opening up as a curtain here to provide the extra length that they need, or just removing any barriers that might be at the front of the stall to allow that cow to lunge past the support posts. If you can't add length, if it's just impossible to do that, then you need to select a divider that will allow them to lunge to the side. As I mentioned, they don't like to lunge to the side, but they will if they have to in getting up. It just takes them longer to do that. But you need adequate space, and we figure that's 24 to 30 inches square. And something else you might want to determine is take a few stalls out of that row and consider adding 4 to 6 inches to the width, so that cow can rest more diagonally in the stall, so she can kind of straighten out that lunge more than she would if she was jammed up against the wall. Freestall width, again, determined by the largest cows in the group, is 48 to 52 inches on center, depending on that cow. Realize this is a center to center dimension. And so the actual clearance is whatever the divider width is minus these numbers. And so we want to provide enough space so that they're not interfering with the next cow in the stall. But these numbers over the years, as long as there's adequate length, you can see resting postures like this where the stalls are open, there's none skipped because of lack of space. So the freestall structure is really important. That's something that's changed in my career. Is the structure has gotten better, as well as the dimensions that actually accommodate cows that are using them. The neck rail's position is to discourage cows from moving too far forward in the stall when they enter it. You want to preserve that lunge space. It's not there to bounce the cow into the alley when she's getting up so that she puts manure and urine in the alley. It's again determined by the largest cow in the group. It is also adds rigidity to the structure, so it's very important. But what I like to see is when cows get into a stall, they don't crawl into a stall, they lie down on it. And so they want to get all 4 feet on that stall surface, backbone level, front and rear legs square under her. So she's not bowed up and she's not V'd in her legs. Everything's square, and maybe just touching the neck rail with her head below the neck rail. I'm very confident that cow can go into the reclining position and also get up, use it when she wants to rise very comfortably. If you've got cows that are standing in the stall with their head above the rail, they're standing diagonal in the stall in order to get all 4 feet on, they're perching, they're half in, half out, or they're pushing really hard against that neck rail to get into the stall, then that neck rail either needs to go up or forward. So it's either too low or too far back. In my career, the neck rail clearance has gone from 36 inches to 50 inches. In allowing these cows to get in and use these stalls a lot better. One quick check as far as if the neck rail's in the right place. I know I probably shouldn't have brought math into this presentation, but the Pythagorean theorem still works. A squared plus B squared equals C squared, and C is the hypotenuse. So if we take 50 inches here as A and 68 inches as B, and we go through this equation, we find out that 84 inches, if we've got 84 inches, 7 feet from the neck rail to the cushion of the stall, I'm very confident the cows can get into that stall. If you're looking at 46 inches, then you might go up to 72 inches on your vertical or on your horizontal distance. There's a little bit of range here that works, but I'm pretty confident if you've got 84 inches, large cows will use that stall. Brisket board location, its purpose is to discourage forward movement when the cows are resting, but you need to provide that adequate body space for comfortable resting. Again, size for the largest cows in the group. Too often, brisket locators are positioned in an attempt to keep the stalls clean. And if cows don't use the stalls, they stay very clean. But we want cows to use these stalls and rest in them comfortably. If the brisket locator is improperly positioned, it can create a restless posture. The cow is actually hanging off the back of the stall. And in this, you don't see it in real time, but in time lapse, there's a lot more rear leg movement, which creates hock injuries and swelling. And so we want to get that cow up on the stall. So if we do that, if we provide that space she needs, that 68 to 72 inches, and really I like to see cows resting 4 to 6 inches ahead of the rear curve. That puts them in a restful posture. That rear leg movement almost stops. And as an added benefit, they bring their tail up on the stall rather than laying it in the alley. You can find some guidelines as far as freestall design and tie stall design on our website, on the Ag Engineering website. You can use this web link or just put in your search engine Penn State Dairy Idea Plans, and it'll take you right to that site where you can see some freestall plans, some tie stall plans, as well as building component plans such as ridge ventilation design, feeding area design, and then there's freestalls as well. Can you tell the difference between a freestall cow and a tie stall cow? The answer I most get is that the freestall cow has a number and the tie stall cow has a name. But I think their genetics are probably pretty close. And so we learned a lot from tie stall design, I think, from what we've learned from freestalls over the years. In those tie stall dimensions, now in the tie stall, the cow is using the feeding area for lunge space, but we want to provide that adequate body space. And that's going to be that 68 to 72 inches for large breed cows and 64 to 68 for medium frame. I learned a number of years ago that there's no such thing as a small framed dairy cow. They're medium and large. So we want to see those same kind of the opportunity for those same common positions that we saw with the freestalls, the short position, the narrow position, the long and the wide. So that neck rail needs to come up, and that's kind of similar to what's in a freestall and also at the feeding area in freestall barns, is that 48 from where the cow is standing, 48 to 50, to have that neck rail there. Again, same posture so she can get in and recline more comfortably. But as that neck rail goes up, the chain needs to get longer because we want that cow to go in the short position and put her head back on her ribs. You can see here in the lower right, that cow doesn't have enough length to do that. And so she may be under some stress as a result of that. So how do you improve tie stalls? Well, it sounds easy, but just move the curb forward or the gutter back. But we know that's going to be more difficult than we see. But what I found interesting after I put this idea out to a number of ag engineer friends is what I got back is actually removing the gutters, creating basically a scrape alley rather than that. They removed the gutters, added a little length to the stall, put some bedding retainers in, and then now they're cleaning that center alley as a gutter or as a scrape alley now, rather than a service alley and gutters. And you can also increase the width because a lot of stalls are 4 foot, and really for large frame cows, 4'6" is preferred. 4'3" kind of is a minimum. That's going to reduce the number of stalls per row. But I have people who've replaced stalls, put in either lost a stall or two in a row because of this extra width. And what they find is they see no difference as far as the milk tank, but they see a lot of improvements as far as comfort. And then the next thing is raising the tie rail, the neck rail in the tie stall. Or again, early in my career, we looked at that neck rail being 32 inches on tie stalls, single rail tie stalls. Now we're up to the range of 46 to 48. Or you can replace and there's a lot of new different types of stalls that do allow some adjustment. Some can actually be attached to the existing curb if there's enough structural integrity there. And believe it or not, I have suggested in some cases to maybe consider a medium frame cow rather than a large frame cow, which, I said it tongue in cheek, but have had some people do that and are very pleased with the results as far as stall use goes. So looking at the resting surface, cows prefer a bedding depth of somewhere in the range of 4 to 8 inches. They really don't care what type of bedding is there, organic or inorganic. They just want that extra cushion and conforming that generous layer of bedding gives you. There are a lot of good choices of fabric covered mattresses and resilient mats, but they only replace some percentage of the desired comfort that deep bedded stalls give it. And so you need to put bedding on top of these, not only for added comfort, but also to absorb liquids and milk. But it's difficult quite often to maintain an adequate bedding layer on these stalls unless you keep right after it. And a lot of people do, and fine. So one answer is to use a bedding retainer, which establishes a layer of bedding between the cow and the stall bed. And it can, in many cases, it's reduced hock injury incidents, improved cushion, and improved cleanliness. Well, sometimes not. This is how that stall is managed. But you don't have to go nuts. You only have to provide about 2 inches of extra height above the mattress in order to get to establish that and need to do that. I've had so many producers that have gone to 3 and 4 inch bedding retainers, but they never fill it more than 2 inches deep, and it becomes very difficult to maintain. It will retain more than bedding. It doesn't sort bedding from manure and urine. It may not save bedding. In fact, you may use more, but it's keeping it in a place that's going to offer more benefits. Also, depending on the type you use, if you just put a big lump there in the back of the stall, they really don't like it. The best bedding retainer is one you don't see because the bedding is up to its level and covering it. And it may reduce available body space. And if that was challenged to begin, this is just an example of a bedding retainer that's put in a freestall barn where it's a metal plate attached to the rear curb. And then they put bedding on top of that. And as the vet told me, it saved this herd from what they were using before. They had a lot of hock injuries, a lot of lameness incidents. But once they put this in and started using an appropriate amount of bedding, things really turned around for them. So inorganic bedding, usually sand, ground limestone, or wet lime is used. It should not support bacteria growth, but you get enough organic matter in there and it will. The purpose is to drain moisture away from the cow to help keep her dry. Usually most inorganic bedding systems require 25 to 50 pounds per stall per day. Reducing that volume reduces its effectiveness. So bedding addition is usually 1 or more times per week. This provides a more consistent stall bed elevation. When you do it less often than that, you start to see piles of sand, and all of a sudden the clearance between the neck rail and the stall base and makes it difficult to get in. So cows just simply will use their front legs to just take sand out so that they can get in, leading to sand waste. And then quite often midweek, you need to level that stall. Because as the cow is using it, it depresses it, pushes material off to the side. And so leveling it, again, helps with that acceptance and comfort for the cow. And then removal of, maintaining those stalls at least 3 times per day to remove manure and wet spots and fill those holes with dry material. Organic beddings, there's quite a range of what's used, from everything from, kiln dried sawdust to dried manure solids. What organic beddings do is absorb moisture, increasing their ability to increase bacteria populations. So maintenance becomes very important there. The ones that are winning the game usually remove bedding from the rear half of the stall daily and replace it with fresh bedding. I know that sounds like a lot, but it really does make a big difference in the comfort and condition of those stalls. Same thing. Now, I say grooming stalls 3 times per day here to remove moisture and manure and things like that. But we all know sometimes it takes more than that. If a cow is resting, as much dry matter is going into a cow, and if she's resting 10 to 14 hours a day, manure is going to come out when she's resting. And so there's a good chance occasionally it's going to land on a stall. And so you need to adjust management in order to take care of that. So as far as resting area design and installation, that's the engineering stuff that we've worked on to encourage cow use and provide that comfort and confident footing and promote cleanliness and so on. but it's really up to the caregiver to ensure that that's a clean, dry, comfortable resting space, and need to adjust their management in order to realize the cleanliness and good udder health that it can provide. So a lot of responsibility is on the caregiver and how those stalls are managed, how well they will use them.
Hey, Dan.
Yes, more
And
questions?
yeah, maybe you're going to get to this, but somebody was asking about the positioning of a water bowl in the tie stall design. Where do you advise folks position the water bowl? On the feed alley side or between the cows and the lying zone?
The most common response I give is, do you want a wet feed area or a wet stall? So I would say most folks that I'm working with prefer to put it on the feed side. Now we'll get to it a little bit as far as access, but that's usually the preferred thing, but we don't want the structure to inhibit cows from getting into that. And so we'll talk about that here in just a bit, and maybe it'd be more help with that. Any other questions?
Yeah, somebody was just asking about the slides. Everybody's excited about the information. You gave us a handout, and we're posting that on our website.
Yeah.
It has much of this information, I'm assuming, right?
Well, I gave you some additional handouts. If you want to turn
Okay.
this into a PDF handout, you're more than welcome to do so.
Okay. And then it will be recorded and
Okay.
put online afterwards, so people
Okay.
can always re-watch it
Yep.
too if they want.
I just mentioned here, we've done a number of webinars over the years on individual housing or individual topics like this. And if you look at Penn State Technology Tuesday webinar recordings, I think there's a lot of those still online that you can pick from. And if you have problems getting to that, feel free to contact me and I'll try to get the information to you. But that might be more helpful as you want to get more in depth, because I'm just doing a bird's eye view of this stuff. So I can give our presentations on each one of these.
Right.
And I'm sure you're not ready for that today, but okay.
So all right.
We'll look at the
Keep
feeding area here. We want to encourage and allow the proper amount of dry matter intake for each cow to have. This is important for each cow, not the majority. Provide a comfortable feeding experience so they're not experiencing pain. Feed available at least 21 hours a day, easy to clean and easy to keep clean. And the most thing you need to keep in mind is even an engineer can feed a hungry cow. We're not trying to feed hungry cows. We're trying to feed satisfied cows so that they eat more and turn more of that into milk. So as far as feeding space, if you want all the cows to eat at once, we want to have at least 27 to 30 inches of feed space available to them. If you're using a TMR and you have feed in front of them within reach and cows are there to eat it, you can get by with 18 inches with good feed bunk management. For dry cows, that's a group that we're not feeding like lactating cows. We want them the opportunity, all the opportunity to get to the feed that's put down. And also post-fresh cows, same thing. Want to have the opportunity for those cows so that they can peak and produce milk. We look at the different freestall housing designs here, 2-row head-to-head freestall with 84 stalls and a 3-row group with 84 stalls. And the feed space available for the 3-row is 33% less than what the 2-row is in this case. So about 30 inches of feed space for the 2-row, about 20 inches of feed space per cow or per stall in the 3-row. And so 33% less. That means that pile of feed that's available to them either needs to be higher, wider, or put down more often so that all the cows have the same opportunity at that ration. We look at tie stall feed space, 4 feet to 4'6" ought to be enough for a cow, to do. And so their lineal feed space is not a problem. Well, sometimes it is. Sometimes it isn't enough for the cow next to her. But we do have producers that have taken those dividers out and feed a TMR. And their idea is, hey, if the cow next to her, she wants more feed, maybe I ought to put more feed at her stall, is kind of their guideline. The difference now between a tie stall and a freestall is a freestall usually has 16 or 18 inches of curb to pile feed up against, and in a tie stall it's usually in the range of 4 to 7 inches. And so that's something to keep in mind. So feed needs to be delivered more often because you just can't put the same volume of feed down in front of a tie stall that you can a freestall or loose housing facility. We want to keep that cow in a head down feeding position. That's how they were designed. They were designed to graze. They don't grade, they graze above grade. They're not horses. They eat above grade rather than below. And so in that head down feeding position, they also produce more saliva. The studies indicate 17% more saliva than they would in an elevated bunk. People argue with that. I say, you know, it's not 16 or 18, it's 17. Go do the study yourself. But anyway, we want that feed table then, because they're grazing animals, 2 to 6 inches above where they're standing. That's a natural eating position. We really hesitate to have it at the same level, and below is just not a comfortable posture for cows to eat. And with the addition of mattresses to stalls, this happened in some barns where all of a sudden the mattress was 3 inches higher than where they were standing, and all of a sudden the feed table is either at or below where they're standing, and it's not a comfortable posture for them. As far as feed separation devices, post and rail is very common, and headlocks. Usually headlocks are put in as a management tool as well, to lock them up for check for pregnancies and other vet checks, things like that. But you need to keep that in mind when you're choosing a feed rail. You want to have good access. And then also in a freestall barn, we want to have good access to the feed. And so providing crossovers every 60 to 80 feet, and those crossovers would be anywhere from 12 to 16 feet wide. That provides, you know, more access. We look at this head to head, 50% of the stalls are in an alley away from feed. You look at a 3-row facility, and now 2/3 of the stalls available are in an alley away from feed. And so you want to provide convenient access. It's also, as we'll get to, a good place to put a waterer. But one of the most important things is, are cows available to feed, and is feed available to cows? Again, that 21 hours a day of feedability, so they can eat when they want it. Again, fewer, you know, the people who know nutrition say, you know, more frequent, smaller meals cows like to do rather than big slug meals. They just work better if they've got that available to them. Feed area management in a loose housing system, typically, again, we're back to that, have it available 21 hours a day, deliver feed at least 2 times a day, especially in the summer, where heat can really wreak havoc on some of these rations. A target refusal for maybe 3%, and then a buck density of, so cows can get there. That's the goal. And then it's got to be within reach. It only takes about 20 or 30 minutes for cows eating a meal to push it far enough away so it's not inconvenient reach for those that come up to the bunk next. And so one of the guidelines that's recommended is, when you put feed down for 2 hours, every half hour for 2 hours, push that feed back, because cows like to come up and eat when it's delivered. They like fresh feed. And so keeping it within reach, especially in facilities where feed space may be limited, and especially in overcrowded situations where feed space is limited, keep that feed within reach so that they have availability to it, that the second group coming up has the same availability as the first. Tie stall, same thing. I don't think there's, you know, again, the genetics isn't different. Their needs aren't that much different. This particular herd here, they feed 6 times a day, and they push feed back 6 times a day. And, you know, the performance of this herd really is very good. So I would say that it's working for them. So Jim Spain, University of Maryland, or University of Missouri, he's a dairy scientist there. He says cows should be within 50 feet of water. And I think that's right, and easy in a tie stall, as long as they're in the stall. But drinking water does make up an important, you know, it's an important nutrient. 4 to 5 pounds of water make a pound of milk, and 80 to 90% of that is their total water requirement, the drinking water. Some comes from the ration, but most of it comes from drinking. When do cows want to drink water? Well, after they eat, they've tanked up, they need to add, you know, it's keeping that rumen happy is kind of the guideline. And so you want to keep the mixture in there. So after eating and after milking is when they seem to want to drink more. Some considerations, of course, have it convenient, allow cows to draw water easily. It shouldn't be something they have to work to make, you know, they want it to be available to them when they need it. And of course, good quality water, keep up with peak demand. Cows can drink up to 5 gallons a minute. And so you want to have the ability for each of those water locations to keep up with the demand of those cows, and something that's clean and easy to keep clean, because I've found that cows don't wipe their muzzle with their leg after they're done eating. And so a lot of feed stuff gets into a waterer. A minimum of 2 drinking water units per group in loose housing situations, and the ability to allow 15 to 20% of the group to drink at the same time. And this is really based on milking parlor performance. As cows are exiting from a parlor, that's when they want to drink. And so you want to provide the access for that group. And so 3.5 to 5 inches of accessible trough perimeter per cow is what's recommended. And then provide 3 to 5 gallons delivery at each water station to keep up with the demand there. So water station location, as I mentioned, those crossovers are excellent places. Some research some studies I've done measuring water consumption from each of these areas, and it's pretty consistent in the 3 or 4 barns that I've done. As cows come back from the milking center, maybe 30-35% of the total water consumption is from that water, 40 to 50% is in the middle, and then the remainder is at the far end. And so just another indicator that central crossover is really important, not only for access to feed, but also for access to water. In a tie stall barn, here we are. This is the problem. Often it's a shared water bowl, and often the structure made it difficult for the cow to get into that water bowl and drink. And so you see a lot of splashing, a lot of licking, waste of water in that way. So, a number of years ago, any cow that would stand for me, I would measure from muzzle to pole, and then also measure the space in the water. And what I found is that if you can get 20 to 22 inches clear between the structure and the water bowl, that cow will have good access. She can get her whole head into that, use the water bowl more correctly than if she's coming in at an angle. And so that's been the recommendation, is basically just lower that water bowl. Typically that's enough to get a broom under it, so you can still clean the feed bunk easily, but that 22 inches. Another thing to consider, because there's been some research that indicates, and I've seen this too, is that, a cow can take over a water bowl in a stall and keep a submissive cow that may be next to her away from it. And so providing a water bowl per stall allows a choice for those cows to drink from, even if they might be standing adjacent to a dominant cow. The other thing you do, if structure is limiting that, you can turn the bowl so that now the cow that's in that stall has better access to it. And so that can be something to consider as one per bowl. And the experience I have with people who have done that, they said they've seen a benefit, and some have seen a benefit in milk production, but it's usually because the old water system was so bad that now they're actually getting the water that they need. So, I can't say it's a true study of good shared water bowl versus good bowl per stall. But you got to have that good access and allow that adequate water supply. Again, the demand that's going to do, if your cows are coming in from pasture, guess who gets the first drink if it's challenged as far as supply? The one closest to where the supply comes from. And then it works its way throughout the barn. So of course, water station management, whether it's a trough or a bowl, needs to be cleaned regularly. I see I'm going a little over, but anyway, just a couple things here. Management decisions that affect cow comfort. And
Can I ask a quick question before we move on?
Yes, please.
So there's a question from Christine about feed height in round bale feeders. Because we have many folks that use bedded packs,
Yep.
So it is 18 to 48 inches above standing surface. Do round bale rings or feed wagons impact cow eating abilities?
Not necessarily the eating, maybe the saliva production. Again, that's more of a dairy scientist question than an engineer's. But that elevated feed bunks in the past, H bunks, J bunks, came into fruition because of bedded pack housing. And in fact, looking at the literature about elevated feed bunks one time, I came across a paper that said to provide railing on top of the bunks so that cows didn't fall into them in the spring. So as the bedded pack went up, They didn't want them to fall into the feed bunk. And so I think, if you can keep that 18 inches isn't bad. I think a foot is better. I mean, it's going to be on the design, but again, if the bedded pack if where they're standing is above, a comfortable eating position, it might affect how they eat that. Now, if it's a round bale, they're going to have some room to eat up higher, that type of thing. But I think trying to keep the area adjacent to that ring, what am I trying, floor level, basically, scraping manure and so on away from that area so that it doesn't get into that. If I'm understanding the question properly. But I think, that head down position is what's typical. And so I think we ought to kind of use that as a goal at least.
Okay.
Anywhere close to answering that question.
She'll type more in. I think if she needs more info.
All right, thanks.
All right.
Stocking density. And so this comes into overcrowding. And a simple way to calculate that is just look at the number of stalls, number of cows in the group, and divide it by the number of stalls. In this case, 101 cows on 84 stalls is 1.2 cows per stall, or 20% overcrowding. And I think you need to be really careful as far as going beyond this 20%, depending on what type of housing you're in, because overcrowding will cause a behavior change if it gets too aggressive. There'll be more aggression at the feed bunk. Cows will come in, want to eat, force cows out, that type of thing. Same thing with resting. If it gets too much, there are cows that come and just hammer on a cow till she gets out, and use that stall. It's going to be faster. They're eating faster, larger meals, which is really kind of discouraged. There's less resting time because stalls just aren't available. There's increased idle standing in the alleys, and then also decreased rumination because of it. And then subordinate cows may be the most affected because they just stay away. And so some of the losses are going to be milk yield, lower butter fat or lower milk fat, greater somatic cell counts, health disorders. So it's something you really want to consider. There was a study done at Cornell a number of years ago looking at just these two groups, an evenly populated group and one that was 30% overcrowded. And they looked at average resting time in 24 hours. And what they came up with, the evenly populated group was 61%, and the 30% overpopulated group, that was 91%. Now, if you're taking a test, 91 is always better than 61. But if you're doing stall use, it's not. There were cows standing and waiting for stalls, and so that's going to cause a problem. Rick Grant over at Minor Institute in Chazy says that resting time is reduced 12 to 27% with stocking rates of 120% or more. And the research that's done in most systems is in a 4-row or a 2-row group. So there's more feeding space. Same number of stalls, are overcrowding, but there's more feeding space available. You go to a 3-row system, and all of a sudden feed space is challenged as well as stall space. And that can even be more of a problem. So even reducing, looking at the type of housing you have, really in 3-row facilities, we say 1 cow per stall, maybe 5 or 10% with good feed management. But you really need to look at just, what kind of a benefit you're getting from overstocking. There again, we have a lot of instances where now, because of some of the quotas that have been put on producers, where they've culled cows out of a group and reduced animal numbers, but they didn't reduce the amount of milk that was produced in that group. And so that, that's a tell of what overcrowding can do. And so just looking at this again, Grant's saying that, you get that 120, all of a sudden you're 120 or more, you're starting to affect milk production. And is the economics of losing 12 pounds, does that make a difference in the group? The other is time away from the pen. And this is more for the loose housing end of things in free stalls. But the goal is not to have, again, 75% of a cow's day is eating and resting. And so we want to keep cows in the area so they have the ability to do those two things as well as the other things. But so the goal is less than 3 hours a day. So 3x milking, 1 hour per milking, 2x milking, maybe an hour and a half. It can be slightly over that, but when it gets extreme, you get up to that 6 hours. Here's some research that looks at, comparing 3 hour to 6 hours per day. There was a change in resting time from 2.5 to 4 hours, 4 hours per day, and a change in milk production from 5 to 8. And so you really have to question some of these overcrowding decisions that are being made, and it really depends on the facility that you're in. Also, lameness prevalence is going to increase. And so just kind of finally, I'll kind of wrap up here. What about these tie stall cows? What does your milk market think about cows that are tethered to their stall 24 hours a day, 7 days a week for their entire lactation? And this is one from Nestle, where they mark permanent tethering as critical on their inspections, but they recognize there are some areas with grazing or with temporary tethering and things like that, that for smaller farms that may be necessary. But they also mention, having the opportunities for periods of unrestricted movement and exercise. And I think cows need exercise all the time. So the opportunity to do this, even though it might be inconvenient to untie and tie cows in a tie stall barn, I think it's good for their overall health. And so what do you do for that? You provide some exercise lots, and there's a number of choices based on, the density that you want to have. Pasture, where you might have up to an acre or so of land per animal, where low density, where, 1,800 square feet per animal, because we know what cows can do if they're put in a high density situation. They'll tear that sod right up. And so in that case, we want to, look at those options, or a paved out lot that they can get onto, but we got to provide that confident non-skid footing. And then if they're there for, less than an hour, water ought to be available, or more than an hour, water ought to be available. And if they're there for more than 3 hours, then feed ought to be available as well. And also consider shade. And then as far as that, that fear thing, I think it's important to say that, handling livestock requires folks that realize that cows need to be outsmarted rather than outfought, working with their flight distance and just being patient and outweighted rather than hurried, and just keeping that stress level down. Early in my career, and I took it personally then, I'd walk into a facility and cows would head to the other end because I was different. Now I walk into a group and I'm a curiosity and they're on me. So I think that has to do with improved comfort, reducing stress, and just doing a better job with these animals. So we started out here looking at, there's a lot of benefits to cow comfort, and really productive cows are the ones that are most affected by that comfort or the lack of it. And so as you're looking at your facilities, look at things that maybe could be improved. If you're seeing problems, if everything's working great, don't listen to a thing I say. But if you're seeing some issues as far as injuries and stall use, then maybe consider some of these tweaks to kind of improve things. So with that, I thank you very much for your attention. People say, Dan, how do you do that for an hour? I say, it's no problem. It's usually the biggest problem for the people that are listening to me, to hang in there for an hour. So, but first of all, I want to thank you for attending. Thank University of Vermont Extension Dairy team for inviting me, and hope you got something out of this presentation.
Well, I know I did. I thought it was great. I learned a lot, and really appreciate it. I hope others did too. There was a follow-up question. So for everybody, if you have questions, we still have some time left, so type them into the chat box. And I will start with a follow-up from the prior question. Christine was asking, she says feed tends to be up higher and goes up with the pack. They get fresh bales daily, but they have to work harder to pull apart the bale than chopped feed in a bunk. So.
Yep.
Yeah.
Sounds like all good answers to her question.
Yeah. So are there any other questions for Dan? It's pretty quiet out there today.
Yeah, that happens. Well, I have a soothing voice, they tell me.
Yes. This has been super. Fine-tuned some things, learned some things, and reconfirmed some things. Thank you. Somebody else said, we use rubber on feed alley in 6-row barn, but use concrete everywhere else. What do you recommend for rubber use in freestalls?
That's an excellent question. Unfortunately, I thought I had enough slides, so I didn't include it. Rubber, or resilient flooring, I call it, because there's different textures of it, can really be a benefit. As far as, I like standing on a rubber mat rather than concrete for long periods of time. And so I don't put the same kind of pressure that a cow does. So I think that's a good option. One of the issues with resilient flooring is the the ones that provide the most cushion also expand and contract and cause you know, as far as driving equipment on them and turning equipment especially, they don't last too long. And the ones that are harder rubber tend to last too long and become pretty slippery in that case. So some kind of texture is usually on those, is really the grooving or some kind of wave or something to provide a better footing, and then keeping them dry as possible. But really, when it comes to resilient flooring, I think like the holding area is probably the first place I would put resilient flooring, because you have cows standing there longer periods of time idle. And then I would move to any special cow areas, you know, special treatment areas, short-term or long-term treatment areas where you may be taking care of lame cows that are moderately lame. Then the feed alley and traffic alleys, if possible. But in traffic areas, if they're given a choice, quite often I'll find cows, if the material is a little slippery, they'll find the concrete with a more confident footing. So that's kind of a coin toss in that case. And then one thing to keep in track, and this is what the foot vets talk to me about, is they've been in systems where everything, all the alleys are rubber, and there's not enough. What they end up with is cows with a bunch of long toes, because they're not getting any natural wear from what they might get on pasture or a concrete floor. So really look at the depending, but I mean, it's a good idea. I know a person that a farm I worked with a number of years ago, he put in some grooves that I wish he'd have called me first, but they were an inch wide and an inch deep, and they were about 3 inches on center. And the cows just didn't like to walk on them. And so they put rubber over them, which improved things dramatically. And I asked him how he liked it. And he said, well, I think I can add maybe 10 more cows because they got more places to lie down. And I thought he kind of missed the point. But anyway, just, you know, I learned by doing, or learned by seeing. And so these kinds of things are kind of help. But a good question. Resilient flooring is a good choice, but you want to look at the application of what you're trying to do. I know in another herd that I was at, they put rubber in the feed alley, and they were very happy with it. But then when I looked at the stalls, I said, you know, if you improve the structure and the comfort of the stalls, they might use them too, because they found them just standing at the feed alley all the time. And as a good ag engineer on Michigan State, another one of my mentors, Bill Beckert, told me, he says, Dan, if the floors aren't right and the stalls aren't right, then you need rubber. But probably improving the floors and improving the stalls would do more than the rubber. So
great.
Just a thought to throw out.
Yeah, good advice. People are excited. They've learned a lot today, learned about ventilation, and folks are saying thank you. I know I learned a lot. I guess it's a good rule of thumb that when we're most comfortable temperature wise, so aren't the cows.
Right.
I was thinking,
that's right.
Gosh, if really 77 degrees, it doesn't, seem always that hot. But I was thinking about last year when we had so many days over 80 degrees. It was a pretty tough summer.
Yeah.
It was relatively dry, but nonetheless, it was still warm. And I know a lot of people struggled with that. So hopefully they got some good tips here.
We had a really tough July last year.
Yeah, it was definitely same for us. So great. Well, we have time for one final question. We're wrapping up. We have 1 minute left. Anybody out there have a question they want to ask, or a comment, I guess, is always welcome too. That sounds like we're going to have you back, Dan. Maybe next year we can actually have you in person.
Maybe.
Which would
possible.
be fun. Yeah. And
yeah.
keep learning, because I think, like you said, there's so many aspects that you could talk more about. And it sounds like that would be helpful to folks too.
Okay.
All right. Well, so with that, we're at 2:00, and yeah, thanks everyone for attending today. And like I mentioned, our next webinar is on Tuesday, March 16th, same time, with Sid Bosworth and Kurt Kotanch, and they're going to be talking about forage quality, and another thing that makes cows happy, good feed. So with that, I will say goodbye to everybody and thank you again, Dan. I know our paths will cross again, and have a great day.
Okay.
Thank you. Thanks, everyone.